Hi everyone, so here's the latest update on the simulator. Lately I've been working on porting the simulator to Unreal Engine 5 to use all the cool new features. But here is one update, one feature that was in the queue for a long time, and that is of course the Turbulence model. So here I just have some volumetric noise. Doesn't seem like anything special, but what's cool about it is that it's not texture based, so it will not be repeating in any direction, and it can be defined in a special way, and that is by using specifying the waveform of the noise with arbitrary number of frequencies with amplitudes, so an arbitrary number of wavelengths. So how this works is, for example, right now I have only this one, so you can see this one is amplitude 0, so it's not contributing. I have only 1 meter sized noise here. So these squares on the floor are approximately 1 meter, so in simulation size. So this is what the noise looks like. And if I, for example, add a wavelength of 4 meters here, so I'll remove this one, so this one looks like this. And I can of course combine them any way I want. So that's cool in itself. But what I need the vectors, right? So to make to have turbulence, I need vectors. So I used this noise to calculate gradient vectors of that one. So it looks like this. So now if I don't know, I'll go to some interesting area. For example, I'll go where this is changing from positive to negative or something like that. Yeah, I can go here. And these blue arrows, they represent the gradient vectors. So that's also cool. But the problem with gradient vectors is that if I apply that to particles, for example, if I were to have something floating in the air, like leaves or something like that, and I let them follow this vector field, then they will end up clumping together in wherever the sink in this field is. So for example, it would be, I don't know, here somewhere, or I think it's in red parts of the scalar field. So if I find some red part, like here for example, maybe, yeah, I have probably something red here. Yeah, so if I pull this one here closer, so you can see that all the arrows are kind of sinking into this one. So what I really need is to have curl field. So I need actually to have gradient of the vector field to have it at 0. Actually, I need the only the curl vectors to drive my particles, otherwise they would end up clumping together in these red parts. So for that I implemented kind of, I don't know, maybe some heuristic algorithm, or I don't know if it's used or if it has a name, but it is definitely useful and cool, and that is this field. So from the same field, from this gradient and this scalar field, I actually generate curl field which is orthogonal to the gradient vector field, which kind of seems simple in 2D sense, where you have one dimension fixed, but in 3D it's not so straightforward. And you can see that they are always like curling and swirling, and that's exactly what I need here for turbulence. So that is the end product. So the end product is this red arrow field where I have turbulence defined by arbitrary number of frequencies, actually wavelengths and amplitudes. So I can define my waveform any way I like, and it is pseudo-random, so I will always have the same field in the same places. I can scroll the origin of this, for example, let it flow downwind or something like that, and I can replicate that just by passing this origin. I can replicate that in multiplayer, so each player in multiplayer would have the same kind of vector noise in the same spot. So that is important, and also it's repeatable. So I can, of course, I can have it. I can have replays or whatever I need. And the one thing that is kind of most important for the future development, because I want to use simulation data for weather, for wind patterns. Usually the grid size of those models is 50 or maybe 30 meters or something like that. So it's not those cells are quite big, and there wouldn't be enough small size noise inside of them, but I can get some kind of measure or of vorticity within the cells, so on subgrid size, subgrid scale, and I can feed that into this noise with amplitudes and wavelengths. So for example, my big wavelength would be, so here it's 4 meters, my big wavelength would be maybe half the grid size, maybe 20 meters or something like that, and I would have some smaller, like half the hang glider wingspan size, like maybe 5 meters. And so I'll just add like this, and then I could also add another and have, for example, small size like 1 meter. And with that I can then read those amplitudes. I can derive those amplitudes from the simulation data. So for example, if it's behind the mountain, I would get this kind of noise. For example, all the large turbulence behind the mountain would be so for example, a couple 100 meters would be simulated, would be directly from the wind direction in the simulation grid. But all the when you go further from the mountain, when the turbulence dissipates, it dissipates into smaller and smaller wavelengths, and I would get those numbers and feed into this. So behind the mountain you would get only just small like bumps in the wind pattern. So that's, I think this is something that will be really cool. For example, if I set all these to 0, so these are just small bumps in the field, and when you fly through those, you would get the correct correct feel for the turbulence in the air. So I'm really excited about this one. So the next step is to get this one into the simulator and try how that feels flying through this. So here, as for the performance, it's really fine, because here, for example, I have almost 150 samples, and they are sampled in real time. So for example, when I move this, they are sampled on each I would say, yeah, on each redraw of these arrows. So that works really nicely. And here, so this curl field is the most computationally intensive, and these gradient and scalar fields are really simple. So yeah, I'm really excited about this one. I hope you like this. I can maybe show you there are also some other things I have in this one. So for example, let me just enable this one. Okay, so this one is so this is just porting to Unreal Engine 5 what is already used for reading aerodynamics for the wing, and this is actually some kind of custom cubic interpolation. So it's in one direction, it is repeating so that it wraps around on, if you would look at it from above like this. So this should actually represent a spherical map. So when you go around the equator, it should wrap around. But when you go to the north or south pole of this spherical map, it should just clamp. It should stay the same value. And so this one is also something that I already use in the simulator, but this one is implemented in Unreal Engine 5, and also it is so yeah, even when clamped, it repeats in this direction. So that's really working fine. I have also some other features like mirroring and things like that. And yeah, I also wanted to pack all these random math stuff. I wanted to pack into separate plugin, into separate project, and hopefully one day maybe just maybe put that on marketplace, or in best case scenario, if the simulator goes well, then I wouldn't have to do that. But yeah, that's also one way of financing the project. So yeah, I hope you like this, and see you in the next update, hopefully soon.